Hello everyone, my name is Luciano. This is my final demo for the frozen pipe detection and prevention system. Hundreds of thousands of families in the US every year experience frozen or burst pipes. The burst pipes are usually caused by frozen pipes. And each one of these disasters will cause thousands of dollars in damages, which in turn presents a significant portion of the total insurance claims that go through every year. And so this is an easily solvable issue if you can monitor the temperature and either automatically activate a heating or have water flow through the pipes, or you can just present the data to the homeowner and they can do what they need to about the issue. So the overall design of my project is you have a temperature sensor and it's connected to a vulnerable pipe. This would usually be located in the basement of a home, close to the outside walls where the coldest temperatures are going to be and the coldest water is coming in. So this temperature sensor can report the data to an Arduino Uno. So Arduino Uno is going to do two things. It'll look at the temperature data and it can power an LED which would simulate a heating element. And the Arduino Uno will also turn the serial data into comma separated values and report this over serial connection to the local computer. Now this computer can compile it into a CSV file, and it'll also host a server on the local network. And the CSV data will be available over this server. Now also on this computer I'll be hosting a Linux virtual machine which will symbolize another component, and it'll be able to request the data, get the data from the local server, and then it can also store it in an AWS server as backup. So there'll be 2 points of storage here. This is a basic overview. I'll go through this on camera, but it's my Arduino Uno, and you have resistors here. The sensor data actually needs to be boosted by the direct power source, and that's what you see going on here. And so we're going to go right into the demo. So here on the bottom right you can see the Arduino Uno, the breadboard, all the electronics. This is the temperature sensor here, and this is some cold water. So the code that's actually running on the Arduino Uno is on the left here. We have libraries from the manufacturer, and what these do is it actually allows the Arduino to interface with the temperature sensor, and it also formats the data for us so it abstracts a lot of the work required. Originally this script was hundreds of lines long, but it can now be replaced with the Dallas temperature sensor. And so here it requests the data, reports it to Fahrenheit, and then separates it by a comma, and it prints each of these as a separate line. The Arduino also, for testing purposes, I have the threshold is 68 degrees, but the Arduino, if it dips below 68 degrees, it will turn on the LED, otherwise the LED will be off. So now I'm going to actually plug in the Arduino here. You'll see things will start happening. I'm going to open up the COM port in the Arduino IDE, and you get temperature data starting to feed in. And actually, if I heat this up, I'm just putting in my hand here, heat up the data, or heat up the temperature sensor rather, and the LED goes off. If I plunge it, it goes back on. So I'm actually just going to heat this up so I can lay it here. And it's in here. Now, I need this data not as a serial stream you see here. So what I need it in is a CSV file. So what does that is, this is actually the result. But here, what this does is it connects to the COM3 port on my computer, connects with a baud rate of 9600. This sets the location for the CSV file. It's actually under the server that's going to be hosted, and I want to timestamp all this data, so I use the library for that. Just gets the current time. This establishes the serial connection and opens up the file to append, and enters an infinite loop where any new day it actually deletes the file and opens a new one. I want to do this so I don't have one CSV file with, weeks, months worth of temperature data. And then, about every second it gets the current data with the current time, parses it all up and formats it, and then appends it to the file. Now, in my Anaconda prompt, I can actually run this, run the Python script. So you'll see it's right here. And with this command, I can run it, and it connects, and you'll start getting Fahrenheit data. Perfect. And it's actually appending it to this file here. But actually, so at the bottom here, you'll see that it's actually updating this to a server, and that's right here. So it's a little sporadic because I have a bunch of data in here right now. So what I'm actually going to do is I'm going to stop this script. And you'll see it stops updating. And what I'm going to do is I'm going to clean out this CSV. Now this will actually cause an error on the web page because it's trying to read an empty CSV file. So I'll restart, and you'll see this special format for the, just separated by the commas, all the data. And it's acting sporadic at the moment, but here we go. So you see about every 1 second, 2 seconds, this file will update, and it's the real-time temperature data. And this is just starting from fresh. It'll provide this data. Now on the camera here, you can see I can hold it in my hand, and it'll slowly but surely start to heat up a little bit. And you can see that spike on the chart right here. And now the LED is off. We're in the safe zone. Now what I'll do is I'll actually put it in the water again. And the LED goes on. And there's actually, so now temperature data is a bit sporadic. Okay, so I'm actually just gonna clear this out again and start the script one more time and let this idle. It's just gonna sit here and run. I'll refresh the page so you can see it come up. It's gonna sit at about 60. It's gonna warm up a little bit because the air temperature is warmer. Okay, so I'm going to stop this because I'm going to run everything in sync in a moment. I'm going to delete this. This is just the basic HTML for the web page. You can see the date here, the time, the temperature, and on every click it saves the CSV data, and this is the chart right here. Now, once I have the CSV file right here, and if I go to the web page, of course I have to restart it. There we go. I can download this data, and I'll just open it up in Excel real quick so you can see. It's only got the first two because I just started it, but this is the current time, 1:20. And what this web page actually does is it'll initiate an automatic download at the start of every hour. So, and it'll just be in Excel named as you just saw it. So if I go over to my virtual machine, there are a few things going on here. This is old data. You can see it's very gradual, and you can actually hover over every piece of data and read it individually. And I'll refresh this to get the current feed, and this will start updating. Now, up here is actually, I'm in a AWS server. So this is actually old data that I transferred earlier. So what I want to do is I just want to remove this file. Okay. And to transport the data, first of all, I would have to download the current hour. So if I do that here, download it. Again, this will happen automatically at the start of every hour, but this is just a demonstration. To transfer this file, I'll run this script right here, send temp data.sh, which is actually this right here, and I'll walk through that in a moment. But what you do is I can run it with this command, and it transferred to here, and this is the new data. And it's all in here. You see it matches the current temperature. So this will run at the start of every hour. And the way this works is, first of all, this is an SCP command. It uses the key pair that's stored on this computer, and it uses these variables to match the specified file format of the CSV. So I have the current year, month, and day, and hour in the name of every CSV so that you can organize and parse through the data. To run this script is actually using cron tab, and this 0 represents the 0th minute. So the 0th minute of every hour, this command will run. And as you saw, this script just transferred it to the AWS server. Now this is already automated. This browser will automatically download the CSV data. The cron tab will run the script, which will transfer to the AWS server, which is always active. So as long as my Arduino is running and this Python script is activated, this whole process is completely automated. And so, obviously the user can access this anywhere on their home network. They can view the data, or they can try to hook it up into some type of heating system, which may or may not be Arduino authorized. The AWS server can also communicate with smart thermostats in the home, can turn up the temperature. You can also try to hook this up to some type of pump where it'll just draw water through the pipes of the home that'll also prevent the freezing. So here in my demonstration, I show how the Arduino Uno can start up, be powered. It can transmit all of this temperature data. My computer will parse it, put it into a CSV, and host it on this server, which offers a web portal to see the most recent data and also the way it's been moving over time. And then this other network device simulated by this Linux machine will take the CSV data and back it up in an AWS server. This virtual machine could also act as its own backup itself. Thank you very much. Bye.